Hello students, we have seen the first chapter which is standard continuous probability distributions. Now in this lecture we are going to see the second chapter which is concepts and definition related to testing of an hypothesis. Now for testing of an hypothesis we need to see the definition of populations samples. Okay, now let's see first population. What is meant by population? Population is the aggregate or collection of all the objects, right? Population is the aggregate or collection of all objects or of their attributes or observations on random variable under consideration. Hence the collection of all the figures of heights of first year students in the university is the population of heights in centimeter. That's the example of population. Okay, so remember this, population is the aggregate or collection of all the data of an object called population. Now a population is finite or infinite according to their number of elements. If number of element is finite, then we say that population is a finite, and if number of element is infinite, then we say that population is infinite. Okay, so according to the finite or infinite case, we say that population is finite or infinite. In most situations, the population may be considered infinitely large. So this is the definition of population. Now next we will see the definition of sample. What is meant by sample? A finite subset of a population is called sample. Remember this. What is sample? Finite subset of a population is called sample, and the process of selection of such a sample called the sampling. Finite subset of population called sample, and process of selection of sample, such a process called sampling process. Now next point, which is SRS. What is meant by SRS? So the SRS, long form of SRS is simple random sampling, right? SRS is simple random sampling. So in simple random sampling sample is a technique of drawing a random sample in which every unit of population has an equal opportunity. Okay, so this is the condition. What is the condition? Drawing a random sample in which every unit of population has an equal opportunity of being selected in the sample. In simple random sampling, which item gets selected in the sample is just a matter of chance. So personal bias of the investigation or investigator does not influence the selection. So that's the simple random sampling, right? So technique of drawing a random sample in which every unit of population has equal opportunity. That's the simple random sampling. So simple random sampling. So this is the short form of simple random sampling, SRS. Now second is SRSWR. So SRSWR is called simple random sampling with replacement. So let's see the definition. When a sample of size n is drawn from a population with n elements, what we have given? When sample of size n is drawn from a population with n elements, then every element in population has same chance of being included in the sample while the items are being drawn one by one. So the unit drawn in a draw, if replaced back in the population before, so if we draw the one unit, so replace it after replace back in the population before drawing second, that's called the simple random sampling with replacement. That is, the unit drawn in a draw if replaced back in the population before next unit is drawn, then such a procedure is called simple random sampling with replacement, or in short we say that SRSWR. SRSWR is the simple random sampling with replacement. So what we have done here, if we draw one by one unit, so replace one before drawing second second sampling, that's called simple random sampling with replacement. Now third type is SRSWOR, means simple random sampling without replacement. So in this case, what will we do? In this sampling procedure, the unit selected from the population are not returned back. And in this process, what we have done? So first, after drawing samples one by one, so first is replaced, then we draw second is replaced, then we draw third in this case. And in this sampling, so the population are not returned back to the population, so they are kept aside, and then the next unit is drawn. While drawing the first unit, every unit in the population has a chance one by one of being included. So in this sample and subsequent draws, every unit has equal chance of being drawn. So among the available units in the population, so in this procedure, one unit can be included in the sample only once. Now we will see the drawback of such a method. Now what are the drawbacks of applying simple random sampling? So simple random sampling has drawback. Applying simple random sampling to large population is that units in the population have to be numbered serially. Now numbering all the units in population may in some cases be extremely costly and physically impossible. So that's the cost of or drawback of simple random sampling. Now we can use simple random sampling without replacement to find expected number of defective articles in the lot. Now also used to estimate per capita income of a certain city. So that's the drawbacks of simple random sampling. Simple random sample, and here we have uses of simple random sampling without a replacement. Now next we'll see the parameter. So what are the parameters we can use? Now parameters are a function of all values in the population such that the population mean can be denoted by letter mu, population variance denoted by letter sigma square, population standard deviation denoted by sigma, and population proportion is denoted by p, are called the parameters. Now next point we will see statistic. So if we have n random sampling, suppose x1, x2 up to xn is random sample from probability distribution function is f of x theta, then t is equal to t of x1, x2 up to xn. So which is so this is the sampling be a function of sample values which does not involve theta, that is which does not involve unknown parameter theta, is called as statistic. Now it is used as estimator of unknown parameters. So the value of this estimator or statistic for given sample is called an estimate of that unknown parameter. Now here, if we have given x1, x2 up to xn random samples of size n from a normal population with parameter mu and sigma square. So mu is the symbol for population mean, and sigma square is the population variance. Then we can define x bar. So this is the this can be defined by x bar is equal to summation I from 1 to n xi. So this xi is we have given x1, x2 up to xn random sampling. So taking the summation and divide by their number, total how many random samples. So this is n. So that's called, so this is the average. X bar is equal to summation I from 1 to n xi upon n is the statistic that defines sample mean. So sample mean is defined by summation I from 1 to n xi upon n. Next, capital S square. So this is called sample variance. Sample variance can be defined by summation I from 1 to n into bracket xi minus x bar bracket square upon n. So what is xi? So we will vary xi I from 1 to n xi minus x bar bracket square. So what is xi? So I runs from 1 to n, we get x1, x2 up to so on xn be random sample of size n. So xi minus x bar bracket square. So suppose we vary this value, we get x1 minus x bar bracket square plus for I is equal to x2 minus x bar bracket square plus x3 minus x bar bracket square plus up to so on xn minus x bar bracket square. So where this x bar is calculated by using this formula. And so a square is summation I from 1 to n xi minus x bar bracket square upon n is called statistic that defines sample variance. And last is sample mean square. So sample mean square is defined by small s square, which is equal to small s square is equal to, it can be defined by summation I from 1 to n xi minus x bar bracket square upon n minus 1. Now value of this function, so here summation I from 1 to n xi minus x bar bracket square, so this value of this will be n into s square. So value of this will be n into s square divided by n minus 1. So this value is the statistic that defines sample mean square. Okay. Now next is sampling distribution of statistics. So let's see the another point, sampling distribution of statistic. Now consider population of size n. If we draw a sample of size n from this population, then the total number of possible samples of size n is. Now for selection we will use combination, okay, and for arrangement we will use permutation. So here we select, so here total, consider population of size total n, from that n size we select n samples, okay, we choose n samples. So we'll use NCN is equal to R. So this is capital N, C n is equal to R, or we can denote this notation by capital NCN is equal to R. Say for each of these R samples we compute a statistic T, that is sample mean x bar or sample variance, that is called capital S square, etc. So then the value of statistic T is may vary from sample to sample. So let we have T1, T2 up to TR be the values of T for the R samples. So each of these value occurs with definite probability. Now that is, we can treat T as random variable assuming values which are T1, T2 up to TR with some probability loss. So this probability distribution of T is known as sampling distribution of T. So that's called sampling distribution of T. Why? So here T1, T2 up to TR be the values of T for the R samples. So each of these values occurs with definite probability, that is we can treat T as a random variable assuming values of T1, T2 and so on are TR with some probability law. This probability distribution of T is called or is known as sampling distribution of T. Now if n is very large, then number of all possible samples is also large, and the values of the statistic may be classified in some in the form of frequency table. Now let's see the standard error of statistics. Let's define it. Now let's see the definition of standard error of statistics. So the standard error of the standard deviation of the sampling distribution of statistics are called standard error, and short form of standard error is SE. Now we will see some statistics. So x bar, whose standard error is sigma by root n. So statistic is P, then its standard error is square root PQ by n. So this is capital PQ by n. If statistic is x1 bar minus x2 bar, then its standard error will be square root sigma 1 square by n1 plus sigma 2 square by n2. And if statistics is small p1 minus p2, then its standard error will be square root p1 q1 by n1 plus p2 q2 by n2, where here n is given as the sample size of that statistics. Okay. Now that's the standard error of each statistic, which is given x bar p x1 bar minus x bar x2 bar p1 minus p2, and that are the standard error of each statistic respectively. Now we will see statistical hypothesis. What is meant by statistical hypothesis? So the statistical hypothesis, a statistical hypothesis is an assertion or conjecture about the probability distribution of an observable random variable under consideration. If the statistical hypothesis completely specifies the distribution, then it is called simple, otherwise it is called composite. Remember this, a statistical hypothesis is an assertion or conjecture about the probability distribution of an observable random variable under consideration. If the statistical hypothesis completely specifies the distribution, then it is called simple, otherwise it is called composite hypothesis. Okay. Now let's see some notation of statistical hypothesis. Now to denote statistical hypothesis, we can use a capital letter H followed by a colon, that in turn is followed by the assertion that specifies the hypothesis. Means here we can use capital letter H for the statistical hypothesis H followed by colon, that in turn is followed by the assertion that specifies the hypothesis. So that's the notation. Now for example, we have given n random sample from population. So the statistical hypothesis that the mean of this normal population is less than or equal to 20 is denoted by. Now here is the notation. We will use capital letter EH. Okay, so EH and then we'll take colon. So EH colon mu. So here mu is the notation. So here followed by a colon, that in turn is followed by the assertion. So what is our assertion? Now here we have given the statistical hypothesis that the mean of that normal population is less than or equal to 20. So mean has notation mu. So mu is less than or equal to 20. So this is the notation for the statistical hypothesis. H colon mu less than or equal to 20 is the notation. Such a hypothesis is composite. It does not completely specifies the distribution, and the hypothesis is if H colon mu is equal to 20 is simple, because here we have given inequality and here we have given equality. That's the simple and that's the composite. So this is the composite hypothesis and this is the simple hypothesis, since it is completely specifies the distribution. So here if we have given mu is greater than equal to type or mu is less than equal to type, that's called composite hypothesis, and if we have directly given equality, that's the simple hypothesis. Okay, we'll stop here. In next lecture we'll see null hypothesis. Thank you.